Inverse of function from graph. Sketch inverse of the given relation. Is the inverse of given relation a function? Write down domain and range of the inverse. Now, first thing is, we are talking this is a relation. It is not a function since it fails vertical line test, right? So for x equals to 0, we have two values, and therefore it is not a function but a relation. Now, sketch inverse of the given relation. To sketch the inverse of this relation, we can adopt one of the two techniques. One is to write down the coordinate points and swap them to get the coordinate points for inverse. So let's do that first. So let me label these points, and let's say this is my point A, B, C, D, E, F. Now point A coordinates for point A is -4, -2. Point B for us is -2, -1. Point C is 0, 0. Point D is 0, 4. Point E is 2, 2. And point F is 3, 1. Now if you have to find inverse of these points, then inverse is basically, if this is x and y, right? Then for inverse, what we do is we just swap x and y and we write y and x. We interchange x with y. That is how we get inverse. And if you do that, you get your inverse function, and the inverse will be, let me write them as a dash. For a dash will be -2, -4. B dash will be -1, -2. C dash will remain 0, 0. So if both are same, that means x equals to y. So they lie on the line y equals to x, right? This is a guideline which I have drawn, which I am going to use in the second technique. D could be written, image of D on the inverse function will be 4, 0. And for E, we write E dash will be 2, 2. This point also called invariant, since its location in both relation and its inverse is same. And for F, the point will be 1, 3, F dash. So that is how you get your points which are representing inverse of the function. So let's plot these points. F, all these points. So let me plot these points using second technique. And the second technique which I am going to discuss is reflection on the line y equals to x, right? So I've already drawn this line in light blue for you, and will reflect each point on this line to get the inverse of the relation. So point A, let's start with this. If you treat this as a mirror, then the image of A will be right across here. Do you see that? So that becomes A dash for you. Now for B. So B is half diagonal away, so it will be half diagonal away on the other side. So you get point B dash. C remains there since it is at 0, 0. Any point on this line will remain there itself, including C and E. As far as D is concerned, if you see one diagonal, two diagonal, so one diagonal, two diagonal, so that becomes a new location for D, and I will write that as D dash. Now E remains there. For F, it is one unit here, so it will be reflected and it will reach this place, and that will be my coordinate for F dash. Now it is time to check. Did we get the same values from both the methods? Let us check. A dash for us is -2, -4. That's correct. B dash for us is -1, -2. That's correct. C dash, which I should write here, is 0, 0. That's correct. D dash is here for us, which is 4 and 0. Perfect. E is an invariant. E and E dash are the same points. E and E dash are the same points. And F and F dash. F dash is 1 and 3. Good job. So we get exactly the same points either method you follow, right? So that is how we can actually find inverse of a function from graph. This reflection method is actually good when you have curved surfaces, right? You really can't get points for all the things. Easier to visualize and reflect. But in a straight line kind of a scenario or points, this is a better technique, right? So we have done this. Now let's answer the rest of the question. Is the inverse of the given relation a function? So if you see the inverse, then does it pass vertical line test? So if you check your points A, B, C, D, E, F, yes it does. So inverse of the given relation is a function. Yes it is. Yes. Yes. And how could you find out from the given relation? If you draw a horizontal line, you will find that the horizontal line really doesn't intersect at more than one point. Therefore, its inverse will be a function. Note, the relation itself is not a function, right? Because it fails this vertical line test. Write domain and range of the inverse. So for domain and range of the inverse, that is my inverse. So I can write all these x values, right? So I can write domain and range set of these x values, and the range will be set of those values, right? So for inverse function, domain dx is equals to these values. So if I start -2, -1, 0, 1, 2, 4. So that becomes the domain, and the range are the y values for the inverse function, and these are -4, -2, 0, 0. So we have to write only once, we should not repeat it, 2 and 3. 2 and 3, right? So that is the range, correct? Now that is how we can actually find domain and range for the inverse function. You will also notice that number of items or elements in domain are more than in range, so there's higher probability of it being a function, right? In this case, that is not the scenario, right? So that is definitely not a function. Correct? So I hope you understand now the concept of finding inverse of a relation from a graph, and also checking whether inverse will be a function or not, horizontal line test. So remember horizontal line test. Let me write down here horizontal line test. So what does that do? It will check if the inverse is going to be a function or not. Okay. Thank you.